Greetings, YouTubers. Thank you for watching this video. If you like the content, please subscribe to my channel, and you can follow. And if you really like this video, please like it. My name is Alaric Granderson, and I am trying to build a parser generator which is extremely useful. Extremely easy to use, extremely easy to implement, extremely easy to set up. And it's so good that whenever you feel like you need a parser, you probably will first think to write your parser in this parser generator rather than write it by hand or use another parser generator. So I first released this parser generator at least 3 years ago. This is one of the latest release. This was the latest release. And I created the algonal parser generator tool. And it was very, very useful. And I will go over like some of the features that it provides. So it has an app that you load the parser that you write, and you hit generate, and it actually generates the code for your parser. And this is in a nutshell what the language looks like. You define these actions, which are the rule for your grammar, and you have a tokenizer. So this parser generator has a tokenizer step. You can discard tokens you don't want, and then it has an analyzer step. And the object point here defines which actions participate in the analyzer step. And yes, so you can pretty much produce a parser. So here's an example. This is an example of a tokenization. And another example, I should be able to show you an example of an analyzation. This is still tokenization. And here's an example of the analyzation, right? Now, after building this parser generator, I realized a few things. This parser generator struggled to parse one of the most simplest languages in existence. It struggled to parse any language. It struggled to parse any. Yes, this is a very, very simple language. And it struggled to parse it. Why did it struggle to parse this language? Let me pull up, if I'm able to, pull up the ini sample. So, as you see in the sample I wrote, only the basic features was implemented. So, it struggled to parse it. But I parsed this. I had to invent a command in order to even parse this language a little bit. I created this command called previous, where the action can take a look at a token that was already parsed. And that's how I was able to parse this language. It's extremely difficult to parse any because the language uses a basic tokenization phase where it just generates simple tokens. So that was one of the limitations of this parser generator. The other limitation was that it struggled to parse white space languages, which Python has indented, and I could not support it. And what I tell the users of this parser generator was to basically take this external function that I created and call it externally. And as you know, people who are trying out something very new didn't really like that. Too much work, and they don't really understand it very much. By the way, guys, this link is now outdated. All right, the new link is Algol Parser machine. So 3 years later, I have decided that I'm going to recreate this parser generator from scratch. And I've already started the work. It's the same each page for the previous version, but I'm changing it around. I am given the source code, not the source code, the actual binaries for the previous version for free. So if you want to try out this parser generator, you can come to my itch page and go ahead and give it a try. I am redesigning the parser generator from scratch. I'm not looking at the old code. I'm writing the code from scratch. I'm designing the syntax from scratch, and I've changed the name. The name is now called Parser Machine, which is more in line to the structure of the parser generator. I have 90% complete the design of the language, which is what this video is about. I'm going to showcase the design of the language. And after this video, I'll be working on designing how I'm going to implement the new parser generator, and then I'll start streaming my implementation of the new parser generator. So if you want to see the syntax of the language for my new parser generator that I'm designing, come to this GitHub page. It's one of my GitHub repos, Algodal, and go to Algodal Parser Machine Manual and hit this link right here. And you'll find the documentation. So this is the most up-to-date documentation of the language, and as I make changes, I'll push the changes here. So I'll briefly go through this. So basically, the way my parser generator structures its generator parser is that you have a virtual machine, which is a shared code base, and the parser itself is binary executable that runs on the parser machine. It parses text and produces abstract syntax tree. That's the parser generator in a nutshell. And I mentioned earlier my previous version, which is the Algodal parser generator. That's the previous version that I am creating a new version for to be better than. And I mentioned some of the pains of the previous version that this new version is expected to solve, and this new version is expected to bring more to the plate. So the language, the Algodal parser generator language. So as you can see, the syntax is completely different. And let me just put the syntax side by side for a brief second. Actually, I'll just use this right here. I'll put the syntax side by side. This is the syntax of the new version. And this is the syntax of the old version. So I got rid of the @ symbol for commands, and instead I just use keywords. I got rid of the angle braces for grammar, and grammars are terminated with a semicolon. And I've started with an equal sign. Right? So this, for example, in the new version, this action right here would be alpha equal text one of any case, because in the old version $sign meant any case. One or more. So this is this old syntax rewritten in the new syntax. Right, so this is our syntax change. I no longer have this @config with entry pointer that. I just have parser, and I put the one in main point. I no longer have a syntax phase and a token phase. I just have one phase. So the old version had two phases: tokenization that generates a token, and then syntax analyzation that analyzes a token. The new version combines them in one for more speed. As you create a token, you start analyzing it immediately. So there's no separate grammar. Tokenization and analyzation uses the exact same grammar. The only difference is this symbol right here has a colon, which indicates that abstract syntax tree is to be generated for this action. Right, now let's continue. So as I specified, two types, that's the only thing that's different. The grammar is the same. You have character sequence short, carsac for short, and syntactic node, syntax for short. They use the exact same grammar, just one just produces AST while one produces a sequence block. That's the difference. And then you have the slant version, for which means pick the first one that match. The old version did not have that. The old version had this command called first. And then the group, the old version had group. And then we have variables. The old version does not have this feature at all. We have range. The old version doesn't have literals like this. I think literals in the old version, the closest thing I had to literals in the old version is curly brace. I'm not sure if I included it. I think I might have included that. Yeah, this is the closest thing I have to a literal in the old version. But the new version definitely have literals. The new version support module, the old version does not. So a parser can be defined as a module, and it can link other parser modules and use them. So that way, if you're parsing a language that uses two different language syntax, you can write one parser for one syntax, one parser for next syntax, and just import the parser for the other syntax in it, rather than having one complex grammar. And then this mentioned the different ways to parse a character, which is character function, the regress blocks, and the literals. Then you got the counter, various counters. So you have the one or more counter, the zero or more counter, zero and one counter, the exactly counter, and the at least and up to counter. Then you have built-in action because for most languages, except probably for space sensitive languages, for most languages, space, new line, end of line are very common things that you parse. So knowing this, you don't have to keep on defining these each time you're parsing a new language. These are not just built in. And some of them, like the end of line, support like certain signals that you just can't parse for. The parser have to know the logic for that, to know the logic for when the file ends that you're parsing. Because this new parser generator that I'm building does not have a tokenization phase, everything is done in one step. There's no feature about discarding a token, right? So you won't have a thing where you can have bracket and the A then the bracket because you discarded the space tokens. You don't have that for this language. So it made up for this using these symbols called the in-between symbol. And you define the config for it and you list out all the things that should be skipped. So the space should be skipped. So anytime it sees a space, the in-between symbol, it makes sure all these things are skipped. And this is the entry point of the parser, and it has what we call lanes. So you have series and options. Lanes are like options, but it's slightly different. And they are syntactic, meaning that they generate AST, and it will choose the most appropriate lane when parsing. I'm going a bit fast, but if you want to take your time and go through this and read it in detail, go through it. If you see any errors or any suggestions, feel free to create a issue and let me know, and I'll work on it to fix it. I will appreciate any feedback. So the abstract syntax tree for syntactic actions are generated automatically, right? But what if you want to control how it's generated? You can. There's a special syntax for that, and you can generate. And here's some example of different type of rules in how to generate your customizing how the AST is generated. We do have a feature called binding power because under the hood, all the parsing follow the parsing. I'm planning to make all the parsing follow the parsing model. So I'm going to have a binding power system that is optional. It's required if you're parsing expression, but it's optional for everything else. Then, of course, variables can give you a lot more power and control. You can create a reflective parser because of variables. If I want to parse something X amount of times, I can parse the value X. How many times should I parse? So you could create a reflective parser using variables. And of course, it has just like constant values, permutations. This is a really cool feature that I've learned about from research. Like, if I want to parse this series, but I want to be able to parse this in any order instead of listing out a bunch of options of each possible order, I just say permutation of these series, and it will do just that. It supports basic logic. It's not extremely complex logic, but very basic logic is supported. and you can use it during your parsing, and logic is defined within the curly brace. It supports if statements. I think maybe this is probably the only parser generator that supports an if statement. I could check that. Only binary format parser generators. I have never heard of these tools. It says Antler has it, but this is more of like a logic block. Oh, you say, okay, if the logic is true, call. If the logic is false, don't call. Interesting. I don't think the way it defines it here is exactly what it means. I think this is a novel. It's a novel thing. Because, okay, yeah, the if, the logic block, and parse this if true, parse this if false, and then continue to parse. Parse this if true, parse this if false, reset the parser pointer and parse this if false, if this is false. So, yeah. Then the text functions that I mentioned earlier. Then the parser result function. So after I parse something, I can check its result. Is Fred? Is part of it that? Is part, that. Yeah. Custom actions. I know I have a built-in way for dealing with very, very complex languages. So if, like, for example, I'm parsing Python, which is very complex to parse because you have to generate dedent and indent tokens using a stack of integers, which you just can't have a built-in feature like that for any parser generator. So for complex things like that, you create placeholder actions and you link them to external actions, and then you would write the external actions in your whatever language you want, C, C++, or a language that supports CABI. And basically you'll write the dedent and indent generator and just link it back to the parser generator, and that's it. Simple as that. And config settings, this is still a work in progress. And you can check out some of the example of how to write a parser in this language. And everything that we just went through, just a quick reference. So I would say that this is 90% complete in the design. Like, some things are iffy, but most of what you see here is I've decided upon, and I'll be going with it. What I'll be doing next, I'll be strategizing, planning how I will be implementing the parser generator itself, the algorithm parser machine itself. So, and then I will start implementing it. So once I start implementing it, I will be streaming it, the process. So subscribe to find out soon and join me soon. Thank you for watching.